Hello chemistry students, Dr. Tellis here. In this next section we will draw structural formulas and name hydrocarbons, recognize and draw structures of geometric isomers and optical isomers, and describe chemical and physical properties of hydrocarbons. Here's just an example of when we are looking at naming hydrocarbons. If we have single bonds, it's an alkane. If we have a double bond, it's an ene, and if we have a triple bond, it's an ine. And here's some examples of geometric isomers. We can see here that I have two black atoms, 1, 2, 3, 4 white ones, 1, 2, 3, 4 white ones, and 2 green ones, but notice that they are arranged differently. And then we have our optical isomers. We can see that there is a mirror plane here, and there's a mirror plane here, and so they are mirror representations of each other, but there's nothing I could do to make them the same. The simplest organic compounds are hydrocarbons, containing only carbon and hydrogen. Hydrocarbons are comprised of carbon and hydrogen, and there's often a third or even additional elements in those compounds. Here are some subgroups. We have alkanes, where we have carbon single bonded to other carbons. Alkenes, how do you remember the differences? Well, in alkene, there's two E's. That's how I remember that there's two bonds. So our anes is one, our enes is a double, and then our YNES, our ines, is a carbon-to-carbon triple bond. And then we have cycloalkanes. Cyclo meaning in a circle or in a ring, and an ane tells me that they're all single bonds. So we have carbon joined in a ring with single bonds. And then aromatic is when I have a hydrocarbon containing benzene rings. So there's double bonds in that ring. This is information that will be helpful, the general formula. For example, if I had C3 and I was told that it was H8, we could figure out that it's an ane simply by going, okay, if my N is 3, 2 times 3 is 6 plus 2 is 8. Yep, this is going to be an ane ending. Our cycloalkanes have this general formula. Our enes have the same CnH2n. Our ines is CnH2 times N minus 2. And then we have our aromatics. Let's look at our alkanes. They have the general formula of this. We take how many carbons there are, times it by 2, and add 2. That tells me how many hydrogens I have. If I have one carbon, its name is methane. 2 carbons is eth. 3 is prop. 4 is bute. And the best advice I have is to memorize meth, eth, prop, bute. Then when you get to 5 carbons and it's pentane, you can remember because a 5-sided shape is a pentagon, and a 6-sided shape is a hexagon, and a heptagon, and an octagon. So that starts to make sense when you get to those numbers. But meth, eth, prop, bute, you kind of just have to remember. Looking at some properties of alkanes. Alkanes are colorless and odorless gases, liquids, and solids. We can see here that methane, ethane, propane, and butane are all gases. Pentane, hexane, heptane, octane, nonane, and decane are all liquids. And then we get into solids when we get into some of those big hydrocarbons. They're generally unreactive, but they do undergo combustion. There's also generally an increase in melting point and boiling point with molar mass. So as we add more carbons and hydrogens, our molar mass increases as we go down. We then have an increase in our melting and our boiling points. They are not polar. We have all carbon and hydrogen bonds, which are nonpolar bonds. All of these hydrocarbons are not soluble in water. Here we have several different ways of representing methane, ethane, propane, and butane. Here's our straight chain alkanes, where we can just see that there's a carbon and 4 hydrogens around it. Here I have 2 carbons, so meth, eth. They're all single bonds, so it's an ane, ethane. We can also say CH3, CH3. And then here I have 1, 2, 3 carbons. This is my longest chain, so meth, eth, prop, all single bonds, propane. Meth, eth, prop, bute. 4 carbons is butane because they're all single bonds. Structural isomers are possible for all alkanes that are larger than propane. For example, let's look at butane. C4H10. I've got a carbon, 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 carbon. So 4 carbons in a row. 1, 2, 3, 4. Around the first one there's 3 H's. Around the second one there's 2. Around the third one there's 2. And around the fourth one there's 3. Here is isobutane, or it's also called 2-methylpropane. It's the same formula. Here's 1, 2, 3, 4 carbons. They're just not all in a straight line. So we can see here 1, 2, 3 carbons are in a straight line, and then 1 carbon is coming off of the middle carbon. It's still C4H10, but it's arranged differently. So they have the same molecular formula as normal butane. But to name this, and we'll get more into naming in a minute, my longest straight chain is 1, 2, 3 carbons. So we would call that propane. And off of the second carbon, we have a methyl group, which is where they get 2-methylpropane. It's still the same formula, which is why it's called an isomer. Let's look at pentane, C5H12. If I had it all in a straight line, 1, 2, 3, 4, 5, it's just pentane. But notice here I could have 1, 2, 3, 4 carbons in a row, and then the fifth one could be off of the second carbon. Or maybe I have 1, 2, 3 in a row, and then I have one coming off of the second carbon and another one coming off of the second carbon. It's still 5 carbons. They're just arranged differently. That's why they're called isomers. So C5H12 has 3 isomers that could be made. C6-hexane has 5, heptane has 9, and etc. Let's draw the 5 isomers of hexane. Are any of them chiral? I always like to draw them straight in a row to get an idea of my first option. 1, 2, 3, 4, 5, 6. And once I have my carbons lined up, then I go back and I put my H's. So off of my end carbon, notice there's only 1 bond, so there's going to be 3 H's around it, 2 around everybody in the middle, and then 3 on the end. And then I double check. 3 plus 3 is 6, 8, 10, 12, 14. Yep, that would be 14 H's. My next option is, what if I had 5 carbons in a row and 1 carbon was off of the second guy? Now it would be easy to say, what if I had one off of the first guy? Well, notice that we know bonds can bend. This guy could bend and essentially be right off of the end here. So this is still considered a straight chain. It's identical to this guy. However, this is not. My longest straight chain would be 5 carbons, and then 1 carbon would be coming off of the second carbon. We can also have 4 carbons in a row with a carbon coming off of the second one and a carbon coming off of the third one. We could have 5 carbons with 1 coming off of the third carbon. We had 5 carbons with 1 coming off of the second. What if we did 5 carbons with a carbon coming off of the fourth one? Ooh, is this different? No, it's actually not. What if I took this guy and I just flip-flopped it? That would be the same as this guy. When you start counting your carbons in a straight line, for example, 1, 2, 3, 4, 5. I look at my branches and I say, here's a branch. I want to number my 5 carbons with the lowest number being closest to a branch. That's why I wouldn't start counting on the right side. I wouldn't say 1, 2, 3, 4, have a branch coming off of carbon 4. No, I want the branch coming off of carbon 2. So if I were to look at this guy, I would start counting 1, 2, 3, 4, 5, and my branch would be coming off of carbon 2, which is the same as this. So far I have 6 carbons in a row. I have 5 carbons in a row with 1 coming off of number 2. I have 5 carbons in a row with 1 coming off of number 3. I have 4 carbons with 1 coming off of 2 and 3. And there's one more option. We can have 4 carbons with 1 coming off of carbon number 2 and a second coming off of carbon number 2. Here are all of those options. There's our 6 in a row. There's our 5 in a row with 1 carbon branch coming off of number 2. There's our 4 carbons with 1 coming off of 2 and 1 coming off of 3. It's okay if you drew it like this with the carbon coming off of the bottom one. It's the same thing. We've got 5 carbons with 1 coming off of carbon number 3. We have 4 carbons with 2 carbons coming off of carbon number 2. None of the isomers of C6H14 are chiral. To be chiral, a compound has to have at least 1 carbon atom with 4 different groups attached to it. Let's talk about naming. The IUPAC stands for the International Union of Pure and Applied Chemistry. The IUPAC system of nomenclature provides a system of naming organic compounds. Using this system, each organic compound gets a unique and an unambiguous name. I know just those last couple of examples were probably a little confusing, but there is a method to it. We know that when we have carbons single bonded to other carbons, those are alkanes, so it will end in an ane. You find the parent carbon chain and add the suffix. The longest chain may not be written horizontally. Step 2. You number the atoms in that carbon chain to give the first substituent or the first branch the lowest number, like in that last example. Then you name and you number those branches or those substituents. You name the substituents as alkyl groups. Use the numbers from step 2 to designate their location. Every carbon belongs to either the longest chain or to a branch, but not both. Each substituent needs its own number. If there are 2 or more substituents that are identical, use prefixes to indicate how many. Like if there's 2 of them, we say di or tri or tetra. And then we use that name of the alkyl group. And then we combine it all. Combine the substituent names and numbers. Alphabetize the substituents, ignoring the prefixes. Precede the name of each substituent by the number that indicates its location. There must be 1 number for each substituent. Separate numbers by commas and separate numbers from letters by dashes. Let's look at some examples. Number 1, let's look at the longest continuous, but not necessarily straight, chain of carbon atoms. Here I have 1, 2, 3, 4, 5, 6, all single bonds. So I'm going to say, oh, it's an ane. Because there's 6 of them, it's hex. But notice that I have a branch coming off of it. I need to number my 6 carbons. And I want to start numbering on the right because I want my branch to have a low number. 1, 2, 3, 4, 5, 6. I don't want to count from left to right because then my branch would have 1, 2, 3, 4. It'd be branch number 5 instead of branch number 2. So I'm scribbling that out. Now we know a single carbon with hydrogens around it is methane. But when it's a branch, it's an alkyl group, which means instead of methane, we say it's methyl. So to name that alkyl group, we change that ane ending to YL. And also notice CH4 is methane. The alkyl group has 1 less hydrogen in it. It was CH3. So it's not methane, it's methyl. So because that methyl group is coming off of number 2, we say 2-methyl hexane. And what's cool is if you were just told this name, you could draw it. Here's what I do. I work from right to left because here's our parent is hexane. So that tells me that there's 1, 2, 3, 4, 5, 6. Off of carbon number 2, there is a methyl group. So a carbon coming off of that. Is it the same as this guy? Yes. You might go, well, wait a second, but your carbon's on the left and this carbon's on the right. But if I were to take this and just flip-flop it, I then have the same thing. Let's look at this next one. 1, 2, 3, 4, 5, 6. My parent name is hexane. Again, it's ane because they're all single carbons. I'm going to number my carbons. 1, 2, 3, 4, 5, 6. So I have a branch off of carbon number 3. Or should I number it the other way? 1, 2, 3, 4, 5, 6. Notice if I went this direction, I would have a branch off of carbon number 3, or I have a branch off of carbon number 3. It's the same. But notice that I have 2 branches. I have a branch off of carbon 3 and a branch off of carbon 4. So I would say 3, 4, dimethyl. So off of 3 and off of 4, I have 2 methyl groups. So 3,4-dimethyl hexane. Let's look at this one. I have my longest chain is 1, 2, 3, 4, 5 carbons. So it's pentane. Notice that off of carbon number 2, I have a methyl. And off of carbon number 3, I have 2 carbons. So it's not ethane, it's ethyl. So off of 2, I have a methyl. Off of 3, I have an ethyl. How do we put it together? You alphabetize it. E comes before M. So we're going to say 3 ethyl, 2-methyl pentane. Pause the video here and see if you can name this structure. Well, let's see how long our straight chain is. I've got 1, 2, 3, 4, 5, 6, 7. My longest chain is 7 carbons, which is hept. How do I know if it's ane? If they're all single bonds, I'm going to total up all of my C's and all of my H's. There were 7 here, carbons, 8, 9, 10 carbons, and if you add up all of the H's, there should be 22, which fits that formula. C10, then I would do 10 times 2 plus 2, which would be 22. So it's an ane. And now I got to number it. I have a branch coming off of carbon number 3, or I have a branch coming off of carbon number 2. I want to count from left to right. So I have a methyl coming off of 2, and I have 1, 2 carbons, so an ethyl group coming off of 5. Now I need to alphabetize it. E comes before M, so 5 ethyl, 2 methyl heptane.